Okay, so let's continue with our integral. We are trying to evaluate this quantity. We'll write this out in terms of, a little more explicitly in terms of the space-time components, but we have two integrals, and we're going to try to put this integral into the form of the function whose solution we have. So let's just write k, the spatial components, we'll just write this as k squared plus m squared to the 1/2 plus I epsilon. I think I missed the 2k squared plus m squared to the 1/2. So we add to that minus to plus infinity d4k over 2 pi to the 4th e to the I ka xa minus xa prime lowered components over a minus e minus k squared plus m squared to the 1/2 plus I epsilon. The same term here, so 2k squared plus m squared to the 1/2. I don't have enough space, but that's that same term. So now let's evaluate this in terms of space and time, because we want to then solve for the part that involves the time, because we know how that integral works. So this becomes the limit as epsilon goes to 0. Let's try to fit this all in one line. Minus, we have minus integral minus to plus infinity. But now we'll break it up into the k0 and the k's. So the k0 we'll just write as e. So it's an integral into e. We still have this term, e to the I k0 x0 minus x prime 0. This is e t minus t prime. We have the part with e goes along with this integral, minus k squared plus m squared plus I epsilon. And then we have, well, we're not going to be able to write all of these together. Let's just break them up. We're still here, right? We now have the integral over the spatial part of the k4 vector. So here it's a 3k. Well, let's put the k squared plus m squared to the 1/2 here, because we're integrating over these values. And what's left here is e to the minus I k vector r vector, spatial part. So we're done with this. Now we have this plus, let's write them here. Let's write that term here. We're splitting it up into space and time parts. So plus minus to plus infinity dE over 2 pi to the 4th e to the I e t minus t prime over, now we have minus e minus k squared plus m squared plus I epsilon. The second integral is minus to plus infinity. Same thing as we have over here, over 2k squared plus m squared, square root. Sorry, same here as well. Missed the square root there. Let's see, d3k, we have the e to the minus I kr for the part of this that involves not the 0th component, but the 1, 2, and 3 components, spatial components. So this is the thing we're trying to evaluate, and we notice that it's not quite in, so these two integrals are not quite in the form of the integral whose solution we know, which is dx e to the minus ixt over x plus I epsilon. And so our goal is to try to massage this term and this term so that it looks like this. So we need a variable x that appears here. We want an x plus an I epsilon here, and then integrating that variable. So we're going to have to massage this a little bit. We're not going to have a dE integral. We want to have an integral where this is our x component. And in this case, it's this.